All right, this is Quiz 11 study guide. Quiz 11. And we're starting with number 2. Number 2 asks you to find the area of a regular hexagon with apothem 17.3. So the apothem is equal to 17.3. Side is 20 centimeters. Side equals 20. It's a hexagon. That's got 6 sides. All right. So the formula is area equals 0.5 times the apothem times the perimeter. You've got the apothem, need the perimeter. If one side is 20 and there's 6 of them, then what's the perimeter? Or the perimeter is 6 times 20, which is 120. So now it's just plug stuff in. All right, the area is going to equal 0.5 times the apothem is 17.3, and the perimeter is 120. .5 times 17.3 times 120. That's 1,038. The dimensions are in centimeters, so this is going to be square centimeters. Number 3. Number 3 asks you to find the area of a regular hexagon with a side length of 7. So, regular hexagon area equals 0.5 times the apothem times the perimeter. Side length of 7, round your answer to the nearest tenth. Alright, so your regular hexagon looks something like this. And one of the sides is 7, and there's 6 of them, so your perimeter is equal to 7 times 6 is 42. Your apothem is what you're missing. So remember, the apothem goes, it's that piece right there, which comes from these dimensions. So I'm going to draw this triangle bigger, and I'm going to work with it. So we're kind of dealing with this now, with this red line being the apothem that we're trying to find. That intersects at 90. If the side is 7, then half of the side is 3.5. This central angle is 360 divided by the number of sides. There's 6 sides. So 60 degrees is this whole angle right here. Half of that angle is 30 degrees, which is this angle. All right? So you've got a 30, 60, 90 right triangle. You can use SOHCAHTOA, sine, cosine, tangent to find the apothem. So in relation to this 30-degree angle, we're dealing with the opposite side and the adjacent side. Tangent is the ratio for opposite and adjacent. So tan 30 equals the opposite side over the adjacent side. If you multiply both sides by the letter A, these two letters will cancel out. You'll have to divide each side by tan 30 to get the A by itself. So tan 30. So 3.5 divided by tan 30 is the apothem. .06. All right, so your area is going to be equal to 0.5 times 6.06 times 42. And that is 127.31. Excuse me? All right, number 4. Find the area of an equilateral triangle with a radius of 8 square root of 3. Leave your answer in simplest radical form. Equilateral triangle, that means all the sides are the same. Area equals 0.5 times apothem times perimeter. Radius is 8 radical 3, so these blue lines represent the radius. This red line represents the apothem. All right, the central angle is going to be 360 divided by 3, which is 120 degrees. If you take half of that 120 degrees, this angle right here is 60 degrees. All right, which makes this a 30, 60, 90 right triangle. You're told that the radius is 8 square root of 3. All right, so this blue segment is 8 square root of 3, and it's a 30, 60, 90 right triangle. The rules related to a 30, 60, 90 right triangle is that the short leg, all right, the apothem in this case, is half of the hypotenuse. So if you take 8 square root of 3 and divide it by 2, it's going to give you the apothem. All right, so 8 square root of 3 divided by 2 is 4 square root of 3. All right, so this piece right here is 4 square root of 3. The long leg, which is this piece of a 30, 60, 90 right triangle, is the square root of 3 times bigger than the short leg. So 4 square root of 3 times the square root of 3 is this piece right here. And 4 square root of 3 times the square root of 3 is 4 square root of 9. And the square root of 9 is 3 times 4 equals 12. So this piece is 12, which makes the whole side of this triangle 24. And there's 3 of those sides. So your apothem is equal to 4 radical 3. And your perimeter is equal to 72. You're asked to leave your answer in simplest radical form. So you're going to just work with this radical 3. You're going to leave it as radical 3. So the area equals 0.5 times 4 square root of 3 times 72. So if you multiply the 3 numbers that are outside the radical, 0.5 times 4 times 72 is 144. So the area is 144 times the square root of 3. That is your simplest radical form. Number 5. Number 5 asks you to find the area of the circle. Leave your answer in terms of pi. All right, the area of a circle is equal to pi times the radius squared. In this case, you're given 5.1, but it's the diameter. If you take half of the 5.1, it'll give you the radius. So 5.1 divided by 2 is 2.55. Your radius equals 2.55. So the area is equal to pi times 2.55 squared. You're leaving your answer in terms of pi, and the 2.55 is still in your calculator, so if you hit the x squared button, the area is equal to 6.5 pi. And that's in terms of pi. Number 6, science. A team in science class placed a chalk mark on the side of a wheel and rolled the wheel in a straight line until the chalk mark returned to the same position. So they took a wheel, they put a chalk mark on it, all right, and then they rolled the wheel until the chalk mark came all the way back down to the bottom. And what they found out, the team then measured the distance the wheel had rolled and found it to be 30 centimeters. So when they rolled this wheel one revolution, it went 30 centimeters. All right? So that 30 centimeters that it traveled represents the distance around the circle, which represents the circumference. And the circumference of a circle, 2 times pi times the radius, is equal to the circumference. Because let me read the rest of this question. To the nearest tenth, what is the area of the wheel? So they're asking you to find the area of this wheel. And the formula for area is pi times the radius squared. So they gave you the circumference, but they asked you to find the area. So with the circumference, you can find the radius, and with the radius, you can find the area. So if the circumference equals 30 centimeters and the circumference also equals 2 times pi times r, you can set the 30 equal to 2 pi r. So 30 equals 2 pi times r. If you divide each side by 2 pi, these will cancel out, and the radius is equal to 30 divided by 2 pi. 2 pi in the calculator, 2 times pi, 6.28. So take 30 and divide it by 6.28. And you get 4.78 as your radius. So now take your 4.78 and plug it into the area formula. So it's going to be pi times 4.78 squared. That 4.78 should still be sitting in your calculator, so if you push the x squared button, the area is equal to 22.82 pi. And while it's sitting in your calculator still, push times the pi button and equals, and you get 71.69 as the area. This is going to be in square centimeters. Number 7. Find the area of the figure to the nearest tenth. It's a sector of a circle. They're just only drawing the sector. So this is 165 degrees. And your radius is 7. The formula for the area of a sector. Area equals pi times the radius squared times the central angle divided by 360. Well, your radius is equal to 7, And your central angle is equal to 165. So it's a calculator problem. Everything's given. Area equals pi times 7 squared times 165 over 360. 7 squared is 49 times 165 divided by 360 equals 22.46 pi. They want the answer to the nearest tenth. So while that's still sitting in your calculator, push times the pi button equals 70.55. Number 8. Number 8 is all in text. Find the area of a sector with a central angle of 110 and a diameter of 6.4. Here's the picture that would go with that. What they're asking you to do is find the area of this piece right here. They're telling you that the central angle is 110 degrees, and they're giving you the diameter. The diameter is 6.4. The formula for the area of a sector, again, is pi times the radius squared times the central angle divided by 360. If the diameter is 6.4, the radius is half of that, so your radius is equal to 3.2. Your central angle is given, it's 110. So your area is going to be equal to pi times 3.2 squared, 10.24, times 110 over 360. So your area is going to be equal to 10.24 times 110 divided by 360. It's 3.13 pi. And push times pi button equals 9.83. All right, number 9. Area of a sector AOB is 16 pi. Find the exact area of the shaded region. All right, AOB. This is 90. This is 8. This is the shaded region that they're asking you to find the area of. Okay? So in order to find the area of this shaded region, we don't have a formula that fits that. But what is in this picture is a sector of a circle that you do know the formula for. Okay, there's a sector. The red region, the boundaries there, that's a sector. Well, if you find the area of that whole sector, and then you subtract the area of the triangle, what are you left with? You're left with the area of the shaded. All right? Let's see, you're told that the area of the sector is 16 pi, so they already give you this. So all you have to do in this problem is find the area of the triangle. Area of a triangle is equal to 0.5 times the base times the height. Well, the base and the height, they're both radiuses. So it's 0.5 times 8 times 8. So your area is equal to 0.5 times 8 is 4 times 8 is 32. So the area of the triangle is 32. They ask you to find the exact area of the region. When they ask you to find the exact area of the region, that means leave pi as pi. If you multiply 16 by pi, you're going to get an approximation. When they ask for the exact, they want the exact. So 16 pi minus 32 is just this. The area of the shaded is going to be 16 pi minus 32. And all of these dimensions were in feet squared or square feet, so this is going to be square feet. All right, number 10 we talked about yesterday, scale factor and finding an area. The trapezoids are similar. The area of the smaller trapezoid is 127. Find the area of the larger trapezoid to the nearest whole number. All right, so number 10, your scale factor is equal to 12 over 45. And yesterday when we were talking about finding the area of similar shapes, we said that the scale factor you take the scale factor and you square it, it's equal to the ratio of the area of the polygons. All right? So in this case, your scale factor is 12 over 45. So your 12 over 45 squared is equal to the area of the two polygons. The smaller area is 127. You're trying to find the larger area. All right, so your scale factor was small shape over big shape. So your area ratios have to be small area over large area. So square the scale factor and crisscross multiply. This problem's a lot easier if you simplify this scale factor first. 3 goes into 12 and 45. So you can simplify this scale factor and make it 4 over 15. So you square the 4 over 15. 4 squared is 16. 15 squared is 225. You set that equal to 127 over area of the larger. So when you crisscross multiply, you're going to get 16a equals 225 times 127, 28,575. Divide each side by 16. These cancel. The area of the larger shape is 1785.94. Number 11. The area of a regular octagon. is 35. What is the area of a regular octagon with sides 8 times as long? So if you've got an octagon and its area is 35, and you need the area of something that's 8 times larger, so your scale factor is 1 to 8. The bigger octagon is 8 times bigger than the smaller one. So your scale factor of 1 to 8 squared is equal to the ratio of the areas. Area of the regular octagon is 35. So you're looking for the larger octagon. So 1/8 squared is 1/64. 1 squared is 1, 8 squared is 64. It's equal to 35 over A. Crisscross multiply. 1 times A is A. 64 times 35. 2240. That was in centimeters, square centimeters. So the area of the larger octagon is 2240. That's something to remember too, guys. If a dimension of a shape is 8 times bigger, all right? If a dimension is 8 times bigger, the area is going to be 64 times bigger. If a dimension of a shape is 4 times bigger, if you got a small shape and this side is 3, and you got a big shape and this side is 4 times bigger, it's 12. All right? 4 times bigger. That means the area is going to be 16 times bigger. Okay? It's the amount bigger squared. All right? The impact of the area is exponential. And number 12. Number 12 says that Mr. Hardy raises earthworms. Be a good business to get in. In a square compost 4 feet by 4 feet. So you got a square. That's 4 by 4. It's 4 feet by 4 feet, and he can put 1,000 earthworms in there. How many earthworms can he have if his square of compost has a side length that is 9 times longer? All right? So the new one is going to be 9 times bigger. So what's your scale factor? This new shape is going to be 36 by 36, isn't it? All right, so your scale factor, if they tell you in the problem that the big shape is 9 times bigger than the little shape, then your scale factor is 1 to 9. All right? So if you take your scale factor and you square it, that's equal to your ratio of worms. So 1,000 over how many worms will fit in the big one. If it's 9 times bigger, 9 squared is 81. 9 squared is 81. So how many worms can you fit in the bigger one? 81,000 worms. Yeah. So if you take your 1/9 and square it, you get 1 over 81 equals 1,000 over W. Crisscross multiply, well, your W equals 81,000. That concludes my presentation.